Solve 12x squared minus 4x minus 5 equals 0 using the quadratic formula. Notice that the equation is of the form ax squared plus bx plus c equals 0. Rewrite the equation to identify the constants. Here, a is 12, b is -4, and c is -5. The quadratic formula says the real solutions of the quadratic equation ax squared plus bx plus c equals 0 are x equals the quantity -b plus or minus the square root of the quantity b squared minus 4ac divided by the quantity 2a. Substitute 12 for a, -4 for b, and -5 for c. The negative of -4 is 4. The quantity -4 squared minus 4 times 12 times -5 simplifies to 256. And 2 times 12 is 24. The square root of 256 is 16. So the solutions are x equals the quantity 4 plus 16 divided by 24, which simplifies to 5/6, and x equals the quantity 4 minus 16 divided by 24, which simplifies to -1/2. The number y of northern Rocky Mountain wolf breeding pairs X years since 1990 can be modeled by the function y equals 2/10 x squared plus 1 8/10 x minus 3. When were there about 77 breeding pairs of wolves? To determine when there were 77 wolf breeding pairs, find the x values for which y equals 77. So begin by substituting 77 for y in the given function. To solve for x, first subtract 77 from each side, giving you 0 equals 2/10 x squared plus 1 8/10 x minus 80. The equation is now of the form 0 equals ax squared plus bx plus c, where a is 2/10, b is 1 8/10, and c is -80. The quadratic formula says the real solutions of the quadratic equation ax squared plus bx plus c equals 0 are x equals the quantity -b plus or minus the square root of the quantity b squared minus 4ac divided by the quantity 2a. Substitute 2/10 for a, 1 8/10 for b, and -80 for c. The negative of 1 8/10 is -1 8/10. 1 8/10 squared minus 4 times 2/10 times -80 simplifies to 67 24/100, and 2 times 2/10 is 4/10. The square root of 67 24/100 is 8 2/10. So the solutions are x equals the quantity -1 8/10 plus 8 2/10 divided by 4/10, which equals 16, and x equals the quantity -1 8/10 minus 8 2/10 divided by 4/10, which equals -25. Because x represents the number of years since 1990, x is greater than or equal to 0. So there were about 77 breeding pairs 16 years after 1990 in 2006. Part Part A. Determine the number of real solutions of 2x squared minus 3x minus 1 equals 0. Notice that the equation is of the form ax squared plus bx plus c equals 0. Rewrite the equation to identify the constants. Here a is 2, b is negative 3, and c is negative 1. Use the value of the discriminant to determine the number of real solutions of the quadratic equation. The discriminant is b squared minus 4ac. Substituting 2 for a, negative 3 for b, and negative 1 for c, you get the quantity negative 3 squared minus 4 times 2 times negative 1. The quantity negative 3 squared is 9, and 4 times 2 times negative 1 is negative 8. 9 minus negative 8 is 17. 17 is greater than 0. Because the discriminant is greater than 0, the equation has two real solutions. Part B. Determine the number of real solutions of x squared plus 4 equals x. First, you want to rewrite the equation by subtracting x from each side, giving you x squared minus x plus 4 equals 0. The equation is now of the form ax squared plus bx plus c equals 0. Rewrite the equation to identify the constants. Here a is 1, b is negative 1, and c is 4. Again, you want to use the discriminant to find the number of real solutions of the quadratic equation. The discriminant is b squared minus 4ac. Substituting 1 for a, negative 1 for b, and 4 for c, you get the quantity negative 1 squared minus 4 times 1 times 4. The quantity negative 1 squared is 1, and 4 times 1 times 4 is 16. 1 minus 16 is negative 15, and negative 15 is less than 0. Because the discriminant is less than 0, the equation has no real solutions. Find the number of x-intercepts of the graph of y equals 2x squared minus 4x minus 3. To solve this problem, you want to determine the number of real solutions of 0 equals 2x squared minus 4x minus 3. Notice that the equation is of the form 0 equals ax squared plus bx plus c, where a is 2, b is negative 4, and c is negative 3. Use the value of the discriminant to determine the number of real solutions of the quadratic equation. The discriminant is b squared minus 4ac. Substituting 2 for a, negative 4 for b, and negative 3 for c, you get the quantity negative 4 squared minus 4 times 2 times negative 3. The quantity negative 4 squared is 16. And 4 times 2 times negative 3 is negative 24. 16 minus negative 24 is 40, and 40 is greater than 0. Because the discriminant is greater than 0, the equation has two real solutions. So the graph of y equals 2x squared minus 4x minus 3 has two x-intercepts. Solve the equation using any method. Explain your choice of method. Part A. X squared minus 4x minus 7 equals 0. The coefficient of the x squared term is 1, and the coefficient of the x term is an even number. So solve by completing the square. Begin by writing the equation. To complete the square, you first want to add 7 to each side, giving you x squared minus 4x equals 7. X squared minus 4x is of the form x squared plus bx, where b equals negative 4. So to complete the square, add 2 squared to each side. X squared minus 4x plus 2 squared is a perfect square trinomial and factors as the quantity x minus 2 squared. 7 plus 2 squared simplifies to 11. To solve the quantity x minus 2 squared equals 11 for x, take the square root of each side, giving you x minus 2 equals the positive or negative square root of 11. Then add 2 to each side, leaving you with x equals 2 plus or minus the square root of 11. So the solutions are x equals 2 plus the square root of 11, which is approximately equal to 5 3/10, and x equals 2 minus the square root of 11, which is approximately equal to negative 1 3/10. Part B. The quantity x minus 2 squared equals 64. The equation has the form x squared equals d. So solve by using square roots. Begin by writing the equation. Then take the square root of each side, giving you x minus 2 equals positive or negative 8. Then add 2 to each side, leaving you with x equals 2 plus or minus 8. So the solutions are x equals 2 plus 8, which equals 10, and x equals 2 minus 8, which equals negative 6. Part C. 10x squared plus 7x minus 12 equals 0. The equation is not easily factorable, and the numbers are somewhat large. So solve using the quadratic formula. Notice that the equation is of the form ax squared plus bx plus c equals 0, where a is 10, b is 7, and c is negative 12. The quadratic formula says the real solutions of the quadratic equation ax squared plus bx plus c equals 0 are x equals the quantity negative b plus or minus the square root of the quantity b squared minus 4ac divided by the quantity 2a. Substitute 10 for a, 7 for b, and negative 12 for c. 7 squared minus 4 times 10 times negative 12 is 529, and 2 times 10 is 20. The square root of 529 is 23. So the solutions are x equals the quantity negative 7 plus 23 divided by 20, which simplifies to 4/5, and x equals the quantity negative 7 minus 23 divided by 20, which simplifies to negative 3/2.